Welcome back to a lecture series on digital image processing practicals in the NV platform. So in this exercise now we are now going to discuss about the assessment of water depth by using digital image processing NV software. Once if you open the NV and we are now going to add the data is taken with respect to the higher resolution data of WorldView 2. It has got 8 band of large scale data information which will attract, as you see, coastal data WV WorldView 2, it is sample data. So this data is being taken up now for the study of coastal depth, and you just fit into the screen by using the Z icon. This is the icon to be used, and then now go on to the sphere. Again there is a spectral analysis tool. So this tool now we are going to use for analyzing the water depth. So this is very much interesting. You see even the impressions, and then you see the depth, and then the movement of water and backwater area, and you see there is an island here and the depth is here, and you see this is shallow blue tone, ocean blue, and even some impressions like the already existing structures remains are noted here. Ships, these are all different ships. Ships are present standing in the coastal oceans. So this is large scale data, 1 meter data, multispectral data. Now we are taking a sphere relative water depth tool. So in this sphere relative water depth tool is being effectively used for this. Now we are giving the input data by selecting the WorldView 2 coastal data, and by clicking OK, and you have to show the place where you are going to set your output. Give next, next. There are many things will come, so you just give simply next for understanding how the water depth is analyzed. Once if we done, the linked windows will come, 3 linked windows. So this is the outcome of normally linear 2 will come. This we have seen, equalization and all. You just fit into the data and then check the depth is represented here with the color gray color. Now you can change the color into the multicolor mode, and you are now very well understanding the water depth of the present. You see this is how you have to do. You remove on, you can change the color even grayscale. Now this is black and white methods of showing. Normally this linear 2 or the simple linears, if you fix and then check your changes, you see the differences in the original data and the depth data, and this is the difference made by the analysis. And you can move the cursor over the image to see the values, data values. You see the data value is 104, the data value bathymetry ratio is 0.6, and then the data value with respect to the depth you can find it over here. So with this we can relate where the depth is more by moving the cursor over into the images of different surfaces. Right, you just see what is the value here. It is 0.8, whereas 0.6. It means the white colors are in this zone. White colors are deeper depth relatively to the darker tone, and you see the values in the darker tones are relatively higher in number. Lower in number, and white tones are higher in number. So that is the order of the changes by moving the cursor into the different places. Where you see 9.9 is the value here. It is more deeper in depth, and you see go to the other places and check. Now it is 0.7. The difference here is 0.9 and 0.7. the depth is relatively more. So this is the pathway for the ship movement to inside, and you can also find the original data value as well as the world view coastal batch. Now if you remove, automatically that will be removed here. So this is how we do the cursor value of the images exhibit in the present exercise. Now just by showing the, this is the cursor movement and depth, even the many architecture you go to archaeological studies, they have used, you take band mass by taking the expression to band, like band 1 you take minus band 1 undefined, you take relative water depth and then select OK, give output file name and give OK. So now you are removing the band from the existing float option, and this is more clear. It is reverse, that the dark tones are deeper in depth, and light gray tones are little higher elevations. Now it is because we have applied the -1, but why we are doing, we will be able to get, white small dots here and there. These are all ships. So once if you apply band math to assess the variations in order to get it, normally this we won't advise for band math for relative water height. And we also can do the 3D DEM model by using this digital elevation model. And you take select 3D surface model view, select the band, 3 bands, red, green and blue. Use the band math associated DEM file for creating the values. This is the, you can put your exaggeration into 50 or 500, or you see that this is the real depth with respect to the from the surface. Of course, it is exaggerated high, exaggerated up to 500 times. Assume that we have higher values in the value. So we have normally, this is why that it is higher. It's like a trench. It's not naturally done. Trench for the movement of what is that your ship into this place. This is the ship. Uh, Ship code, that this is the movement, that's why, otherwise it will not, this is also will be similar to this. And you see, this is a ship, this is another ship, you can find the white dots are different ships present standing near to the coast. You see this one, and this one. So all this is very interesting to assess the depth of the water. When you see the MSS data, multispectral data, you will not know much deep into the depth variations. And once if you take the 3D model like this, and the depth variations are represented in a well defined manner. Okay, you take 3 zones, blue, green and red, give OK, and once if you do it with the exaggeration 500, you can also select the zones, and then you see the deep depth variations. If you give higher depth, the even the variations, are highlighted much better. And this white lines are the ships which is standing near this place. So this white height object, this white height objects are and this white height objects are the relatively height area, right? So with this, the relative discussion is come to an end. Relative water depth analysis, relative water depth extraction, grab the image over relative water depth. So this is comes to an end for understanding this exercise. Thank you very much.